Okay, we've now done steps 1 through 3 for the frame, which was check length, radius ends on the punch press, smooth ends, and deburr on sander. Step 2 says transfer punch hole locations with small hammer. Okay. This is the transfer punch fixture. So what you'll do is you'll set your part on here, making sure that it's back against this back bar, I call it, and slid over to the right against the pin. Then you'll take the transfer punch template. The back bar has 5 countersinks to match the locations of the holes in the transfer punch template. So line it up accordingly. Make sure the template and the part are against the pin and against the back bar. Tighten the little thumb clamps. Small ball peen hammer. Transfer punch. Okay. Transfer punch all 5 holes. Transfer punch should be up and down, vertical. It has quite a bit of play in here. Return the tools. Now, I'll take the center punch and a large ball peen hammer and find a flat surface that's okay to hammer on, like an anvil or our game drill press table. Works nicely. Take the center punch, put it in the transfer punch mark, and give it a good hit with the hammer. We want to make the a good hit. We want to make the transfer punch marks larger, because otherwise it's very hard for the drill to stay in the mark. Okay, now the other items in this block are the drills we need. You'll notice that the drawing specifies 3 holes, 3/16 diameter drill, 1 hole 5/16 diameter, and 1 hole .500 inch ring. Okay. We have a 3/16 drill, a 5/16 drill, a 7/16, which is for the frames, and a 31/64. 31/64 is the next smaller commercially available drill underneath 1/2 inch. If you want to ream a hole, you have to drill it smaller, the next size drill size smaller usually, and then ream it. So we're going to use the 31/64 drill. The drill presses are set up each to run at a different speed. The smaller diameter, because of our RPM formula, RPM is 4 times the cutting speed divided by the diameter. As the diameter gets smaller, the RPM needs to go higher. So we'll put the smallest drill in the fast spinning drill press. And I even labeled it 3/16, drills up to 15/64. We'll put the 5/16 drill in the medium speed drill press. Notice it says for drills 1/4 inch to 3/8 diameter. 5/16 is right in the middle. And we'll put the 31/64 in the slowest spinning drill press. Then I'm going to get the vise with the step jaws. This works very nicely. You do not want to drill into the middle of the vise, as people have done. If you put it in the steps, you don't have to worry about that. Tighten your part. Now, when you drill the holes, don't exert too much pressure on the quill of the drill press, because you can easily break that 3/16 drill. What you want to do is you want to come down, get the drill lined up as close as you can so that the point of it is right above your little center punch mark. And then when you start the drill press, come down and just barely touch it to the mark. If you're centered over the mark, you will not see the drill move, and you'll see a little, when you raise it, you'll see a little shiny ring right around your center punch mark. Okay, so we'll bring the tip of the drill down, just barely touch our mark. Nice little ring right around the mark, and it didn't move. So I'll go ahead and drill the hole. You want to also try to sense when it's breaking through and lighten up on the pressure a little bit. The common time to break the drill is when you're pulling too hard and it breaks through the bottom. Try that. Drill the second one. And the third one. holes, the 3/16 diameter. So 3 of them are finished. The other 2 we will make larger. So these 2 are actually pilot holes for a larger diameter. Now we'll drill the 5/16 hole. This will be a lot easier to drill than if there was no hole already there, because we've got a pilot hole. Very easy to drill compared to drilling through solid material. Now the 31/64. Now this one here, it's important that you hold on to your part. This drill press is on the slowest speed, which gives it the least RPM but the most torque. So don't let it tear the part out of your hand. And it's real important, try to sense when it's breaking through. You'll hear this start to squeal. Squeeze it through gently. So don't try to tear the part out of your hand that way, and you'll get a much smaller burr on the bottom. Now you can leave the part in the vise, carry it over to the sensitive drill press. And you do want to put a little bit of oil on the reamer. So get one of the open top cans. Now the reamer only cuts on the corners down near the tip. So you don't have to oil the whole thing. I'll just wipe a little bit of oil on the corner of it. This is a sensitive drill press. It does not have a lot of power, so you need to ease it through or else you'll stall the spindle. Ease it down through there. Why did we ream that hole? 3 advantages to reaming. You get much better size control, much tighter tolerance on the diameter. You get a better surface finish, and the hole will be more round than if it was just drilled. Now I can go ahead and take the part out of the vise. Put the vise back. The next step on the sheet tells us we need to deburr the holes with the countersink. Green drill press here, remember the gray switch should always be on forward. Use the red and the black start-stop switches to run the machine. Okay. Hold the part near the hole you're going to deburr. Push hard for a short time. You're not trying to chamfer the hole, you're just trying to remove the burr. Now this is a pretty sharp countersink. Does a pretty good job, but it does leave a smaller burr behind. So I will go use the Scotch-Brite wheel to remove that secondary burr. If your parts have burrs, you will lose points for it. Okay, now we need to move over to the other room, because the next step on the handle says to bend using the diacro bender, which is over on the other side. The next step on the frames has been on the press brake in the other room.